Hello guys, I'm from Sri Venkateswara College of Engineering and my name is Parinitham and today I'm here to talk about Quicksort and its time complexity analysis. So contents Introduction to Quicksort, how Quicksort works, analysis of Quicksort time complexity, best case scenario time complexity, worst case scenario time complexity, average case and comparison with other sorting algorithms. We are going to talk about it today in this. Now we are going to talk about introduction to Quicksort. Quicksort is a widely used sorting algorithm that follows the divide and conquer approach. It was developed by Tony Hoare in 1959 and is known as for its efficiency performance. Quicksort is commonly used in many programming languages and libraries due to its speed and simplicity. The algorithm works by selecting a pivot element from the array and partitioning the other elements into subarrays according to whether they are less or greater than the pivot. The subarrays are then recursively sorted using the same process. This process continues until the entire array is sorted. So Quicksort basically uses the divide and conquer approach where if in a sorted array a pivot element is in an unsorted array a pivot element is taken where the pivot element the elements which are lesser than the pivot elements are shifted to its left side and the elements greater than the pivot element are shifted to its right side. And while performing the partition process there are subarrays divided and the subarrays undergoes partition process which further arranges them and then you finally combine them and form a single array. And when we are talking about efficiency, the algorithm's average case is fastest among other sorting algorithms, making it highly desirable for large set of data. So now we are going to talk about the working of Quicksort. So select an element from the array which serves as a pivot. The choices of the pivot can vary, but a common approach is to select first element in the array. Partitioning. Rearrange the array so that all elements smaller than the pivot are moved to the left and all elements greater than the pivot are moved to its right. This process is called partitioning. To achieve this, you can use two pointers, one starting from left end and the other from the right end of the array. Move the left pointer until you find an element greater than the pivot and move the right pointer until you find an element smaller than the pivot. Swap these two elements and continue this process until the pointers meet. After partitioning, you have two subarrays, one with the elements smaller than the pivot and another with the elements greater than the pivot. Recursively apply the same partitioning process to each subarray. This means selecting a new pivot for each subarray and repeating steps 2 and 3 until the subarrays have size 1 or 0. At this point, the subarrays are considered sorted. Combine subarrays. Since quicksorts the array in place, there is no explicit combination recursive calls return. The array is already sorted. Repeat until sorted. Keep repeating steps 1 to 4 until the entire array is sorted. So basically, if the first step is to select a pivot element, either it can be the last or the first element in an unsorted array, and the second step is to partition, where the elements smaller than the pivot elements are shifted to the left side, and the elements greater than to the pivot element are shifted to the right side. And by the use of two pointers, you're going to do the partitioning process. And while doing the partitioning process, when the pointers meet, you're gonna divide the unsorted array into two subarrays and repeat the same recursive partitioning process and sort the complete array. So we are going to talk about quick sort time complexity, best case time complexity. The best case scenario occurs when the partitioning step always produces two subarrays of roughly equal size. In this case, the time complexity is big O n log n, which is achieved when the binary tree representing the recursive calls is balanced. Average case time complexity. The average case time complexity of quicksort is also big O n log n. In the average case, based on the assumption the pivot selection is either random or evenly distributed, leading to balanced partitioning. Worst case time complexity. The worst case scenario occurs when the partitioning step consistently produces highly imbalanced subarrays, such as the pivot is always smallest or largest element. In this case, the time complexity becomes big O n square, as each partitioning step only reduces the size of the array to 1. However, the worst case scenario is rare in practice, and various techniques such as random pivot selection or choosing the median of 3 pivot are used to mitigate it. Comparison with sorting algorithm. Quicksort versus merge sort. Both algorithms use divide and conquer approach, but merge sort offers a guaranteed worst case performance of big O L log n, while Quicksort does not. Quicksort versus heap sort. Quicksort generally performs better in practice, but heap sort has a guaranteed worst case performance of big O n log n. Quicksort versus bubble sort, selection sort. Quicksort is much faster or larger datasets, while bubble and selection sort are only efficient for small datasets. So before coming on to the conclusion, we'll talk about its advantages and disadvantages. Advantages of Quicksort is that it is a divide and conquer approach where it makes us to solve the problems easier, and it is efficient on large data and uses less amount of space to function. Disadvantages of Quicksort: it has a worst case time complexity of big O n square. It is not good choice for small datasets. It is not stable for no, it is not stable sort, meaning that if two elements have the same key, their relative order will be represented in the sorted output. So now we'll move on to the conclusion. Quicksort is an efficient sorting algorithm used in computer science. It employs a divide and conquer strategy and has a time complexity of big O n log n on average. While it has some limitations and drawbacks, Quicksort remains one of the most widely used algorithms today. Thank you for watching. Please like and subscribe.